Right, before us is the summary of the laws of indices. We're going to run through them and explain them one by one. But before we continue, we'll ask ourselves the question, what is indices? Given the number, for example, 2 to the power of 3. This number up here is called the index, and this one is called the base. And this number implies 2 multiplying it 3 times, and this should equate to 8. So operation on numbers involving indices, index involving powers called indices. So the powers called index or exponents. So 9 is also expressed in indices form as 3 to the power of 2, because 3 times 3 equals to 9. I believe this already. Now let's jump right into it and take a look at the laws of indices one by one. The first one is called the product law. The product law. Now let's take an example and see how it holds true. The product law, we have 2 to the power of 3 times 2 to the power of 2, for example. According to the law, this should give us the base, which is 2 to the power of the sum of the sum of the powers. So, and then this should become 2 to the power of 5. 2 to the power of 5, and 2 to the power of 5 is equivalent to 32. That's 2 multiplying itself 5 times. The next one, we'll call it the quotient rule. Let's take, like the first one, the same example, 2 to the power of 3 divided by 2 to the power of 2. According to the law, this should give us 2 to the power of 3 minus 2, which would become 2 to the power of 3 minus 2 is 1, which equates to 2. So that's the second law. And the third law here says a to the power of 0 is equal to 1. That's any number raised to the power of 0 equates 1. How? Let's see. Let's take, for example, 2 to the power of 3. Let's divide it by itself, 2 to the power of 3. So by second law, it should give us 2 to the power of 3 minus 3, which is 2 to the power of 0. So how is this 1? Common sense should tell us that if you divide a number by itself, the answer you will get is 1. That is 2 to the power of 3 divided by 2 to the power of 3 is equal to 1. That is from where the law obtains. So a to the power of 0 being 1 implies that a to the power of a certain index, it has been divided by another a to the power of that same index. And that is it for that one. Now let's take a look at the next one. The next one says a to the power of minus m. The power of a negative is equal to the reciprocal of the power of m. So is this true? Let's check. So let's take a to the power of minus m. This implies a to the power of 0 minus m. This one is true. Therefore, this is the same thing as going by the second law, a to the power of 0 divided by a to the power of m. And we already said in the third law that any number raised to the power of 0 is 1. Therefore, this becomes 1 divided by a to the power of m, which can also be written as 1 all over a to the power of m, which gives us what we are looking for. So a to the power of a negative index is the reciprocal of a to the power of that index in positive. So that is the third one, and the fourth one, oh, that's the fourth one, and the fifth one implies directly that a to the power of m to the power of n is still the same thing as a to the power of m n, which is still the same thing as a to the power of n to the power of m. It doesn't matter whichever one comes first, it's product. So for this sixth one, let's do the seventh one first. For the seventh one, it says a to the power of fractional power 1 all over n is also written as the nth root of a. It's also written as the nth root of a. So if this is true, then it means a to the power of m all over n is the same thing as n root a to the power of m, which is still the same thing as root a nth root of a to the power of m, whichever one comes first. So we have run through it. In our next video, we'll solve some exercises based on these laws. Thank you.